Hello, dear students. We are at the last part of Unit 3, that is classification of elements and periodicity in properties. In the previous classes, we studied classification of elements. We studied atomic radius, ionic radius, ionization enthalpy, and electron gain enthalpy. We studied different properties as well as classification of elements. Today, we will learn one more very important properties of elements. That is study of electronegativity. Electronegativity properties of elements today we will discuss. Fine. First of all, we'll see what is meant by electronegativity, what are the different scales of electronegativity, how the electronegativity varies along the period of the periodic table. We'll see how it varies down the group of the periodic table. What is meant by electronegativity then? Electronegativity is defined as the capacity. It is defined as the power. It is defined as the tendency of an atom. Electronegativity is what? So, it's a power of an atom. It's a capacity of an atom present in a molecule. Okay, it's a power of an atom in a molecule. Why this power, this capacity has? This capacity of an atom in a molecule to attract the shared pair of electrons towards itself. That character, that property, that capacity, that power of an atom in a molecule to attract shared pair of electron towards itself is called electronegativity. Is that clear? Okay. So we'll see this animation over here. Say this is atom A. Okay, can you see here? This is atom A and this is atom B. So this atom A and atom B are held together by a bond, a single bond, a covalent bond, which is formed by mutual sharing of a pair of electrons. Okay, that means we have a molecule AB. ಅದರ ನಡುವೇನಿದೆ A bond B. Okay, so that single bond is formed by what? Mutual sharing of a pair of electrons. Okay, so in this animation, can you see these two red colored dots over here? These are what? A pair of electron, two electrons. Okay, a pair of electrons which are present between this atom A and B under E single bond ಅಲ್ಲಿ ಇದೆ. Now, between this atom A and atom B, one atom has a more power. Between atom A and atom B, one atom has a more capacity. ಎದಕ್ಕಿದೆ ಪವರ್ ಅಥವಾ ಕೆಪಾಸಿಟಿ? ಟು ಅಟ್ರಾಕ್ಟ್ ದಿಸ್ ಶೇಡ್ ಪೇರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ ಟುವರ್ಡ್ಸ್ ಇಟ್ ಸೆಲ್ಫ್. ಈ ಅಟಮ್ ಎ ಮತ್ತು ಅಟಮ್ ಬಿ ಎರಡು ಅಟಮ್ಸ್ ಅಲ್ಲಿ ಒಂದು ಅಟಮ್ದು ಪವರ್ ಬಹಳ ಇದೆ, ಕೆಪಾಸಿಟಿ ಬಹಳ ಇದೆ. ಎದಕ್ಕಿದೆ? ಈ ಎರಡು ಎಲೆಕ್ಟ್ರಾನ್ ಈ ಪೇರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ನ ತನ್ನ ಹತ್ರ ಎಳ್ಕೊಳ್ಳೋದು, ತನ್ನ ಹತ್ರ ಅಟ್ರಾಕ್ಟ್ ಮಾಡ್ಕೊಳ್ಳೋದು ಪವರ್ ಬಹಳ ಇದೆ. ಹಾಗಾದ್ರೆ ದೆನ್ ದಟ್ ಅಟಮ್ is said to be more electronegative than the other atom. In this animation, so it is shown that atom B has a strong power. Can you see here? Atom B has a strong pull. ಅಂದ್ರೇನು? It pulls the electron towards itself. ಆ ಎರಡು ಎಲೆಕ್ಟ್ರಾನ್ ತನ್ನ ಹತ್ರ ಅಟ್ರಾಕ್ಟ್ ಮಾಡ್ಕೋತಾ ಇದೆ. ಅಂದ್ರೆ atom B has more power than atom A. Atom has a less power, weak pull ಅಂತ ಬರೆದಿದ್ದಾರೆ. ಹೌದಾ? ಅಂದ್ರೆ between atom A and atom B, there is a difference of power to attract electron pairs. Between atom A and atom B, there is a difference of what? Electronegativity. Okay, so ಈ ಎಕ್ಸಾಂಪಲ್ ತಗೊಂಡಾಗ atom B is more electronegative than atom A because atom A has the more power, more capacity to attract this pair of electron towards itself. So atom B the power ಜಾಸ್ತಿ ಇದೆ, ಅದಕ್ಕೆ atom B is more electronegative than atom A. Clear? ಹಾಗಾದ್ರೆ what's the definition now? Definition ಏನು? It is defined as the capacity of an atom present in a molecule. Say this is the AB molecule. ಹೌದಾ? ಈ AB molecule ದಲ್ಲಿ ಅಟಮ್ದ ಕೆಪಾಸಿಟಿ. ಇಲ್ಲಿ ಯಾವುದು ಬಿ ಅಟಮ್ದ ಕೆಪಾಸಿಟಿ ಜಾಸ್ತಿ ಇದೆ. ಎದಕ್ಕಿದೆ? ಟು ಅಟ್ರಾಕ್ಟ್ shared pair of electron towards itself. That capacity, that power, that tendency of an atom in a molecule is called as what? Electronegativity. ಕ್ಲಿಯರ್? ಓಕೆ, ಸಿಂಪಲ್ ಆಗಿ ಹೇಳಬೇಕಾದ್ರೆ ಒಂದು ಮಾಲಿಕ್ಯೂಲ್ದಲ್ಲಿ ಒಂದು ಅಟಮ್ದು ಕೆಪಾಸಿಟಿ ಎಲೆಕ್ಟ್ರಾನ್ನ ತನ್ನ ಹತ್ರ ಅಟ್ರಾಕ್ಟ್ ಮಾಡ್ಕೊಳ್ಳೋದು ಜಾಸ್ತಿ ಇರ್ತದೆ ಇನ್ನೊಂದಕ್ಕಿಂತ. ಅದಕ್ಕೇನಂತಾರೆ? ಮೋರ್ ಎಲೆಕ್ಟ್ರೋನೆಗೆಟಿವ್. ಓಕೆ, ಆ್ಯಂಡ್ ದ ಪ್ರಾಪರ್ಟಿ ಇಸ್ ಕಾಲ್ಡ್ ಎಲೆಕ್ಟ್ರೋನೆಗೆಟಿವಿಟಿ. Clear? Very simple definition. Okay, fine. This electronegativity is not a measurable quantity. It do not has a unit. You just recall your memory. The previous property we studied was electron gain enthalpy. We studied ionization enthalpy in previous classes. That ionization enthalpy, electron gain enthalpy were measured in terms of kilojoules per mole unit. ಯೂನಿಟ್ ಏನಿತ್ತಲ್ಲಿ? ಕೆ ಜೆ ಪರ್ ಮೋಲ್, ಕಿಲೋಜೋಲ್ಸ್ ಪರ್ ಮೋಲ್. ಹೌದಾ? ಬಟ್ ಎಲೆಕ್ಟ್ರೋನೆಗೆಟಿವಿಟಿ ಈಸ್ ನಾಟ್ ಅ ಮೆಜರಬಲ್ ಕ್ವಾಂಟಿಟಿ. ಬಟ್ however, a number of numerical scales of electronegativity of elements are developed. For example, ಪಾಲಿಂಗ್ ಸ್ಕೇಲ್. ಬೇರೆ ಬೇರೆ ಸ್ಕೇಲ್ ಇದ್ದಾವೆ ಎಲೆಕ್ಟ್ರೋನೆಗೆಟಿವಿಟಿಗೆ. ಪಾಲಿಂಗ್ ಸ್ಕೇಲ್ ಇದೆ. ವಿ ಹ್ಯಾವ್ Mulliken-Zaffe scale. One more is Allred-Rochow scale. Okay, these are different scales to measure the electronegativity of an atom in a molecule. Okay, and the one which is most widely used is the Pauling scale. Whatever the electronegativity values you come across in your textbooks. Okay, so the common scale we are using is what? Which scale? It's a Pauling scale. ನಾವು ಯಾವ ಸ್ಕೇಲಲ್ಲಿ ಎಲೆಕ್ಟ್ರೋನೆಗೆಟಿವಿಟಿನ ಸ್ಟಡಿ ಮಾಡ್ತಾ ಇದ್ದೇವೆ? ಪಾಲಿಂಗ್ ಸ್ಕೇಲ್ದಲ್ಲಿ. And you know, this electronegativity of any given element is not a constant. The electronegativity of an atom varies. ಅಂದರೆ the electronegativity of an atom is depends upon what? It depending upon the element to which it is bound. ಒಂದು ಅಟಮ್ದು ಎಲೆಕ್ಟ್ರೋನೆಗೆಟಿವಿಟಿ ಕಾನ್ಸ್ಟೆಂಟ್ ಇರೋದಿಲ್ಲ, ಅದು ಚೇಂಜ್ ಆಗ್ತಾ ಇರ್ತದೆ. ಎದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರ್ತದೆ? ಇಟ್ ಈಸ್ ಡಿಪೆಂಡಿಂಗ್ ಅಪಾನ್ ದ ಅಟಮ್ ಟು ವಿಚ್ ಇಟ್ ಈಸ್ ಬೌಂಡ್. ಯಾವ ಮತ್ತೊಂದು ಅಟಮ್ ಜೊತೆ ಜಾಯ್ನ್ ಆಗಿರ್ತದಲ್ಲ ಅದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರ್ತದೆ. ಅಂದರೆ ದ ಎಲೆಕ್ಟ್ರೋನೆಗೆಟಿವಿಟಿ ಆಫ್ ಎನ್ ಅಟಮ್ ಡಿಪೆಂಡ್ಸ್ ಅಪಾನ್ ವಾಟ್? ಡಿಪೆಂಡ್ಸ್ ಅಪಾನ್ ದ ಅದರ್ ಅಟಮ್ ಟು ವಿಚ್ ಇಟ್ ಈಸ್ ಬಾಂಡೆಡ್. ಓಕೆ, we learn how this electronegativity varies in the periodic table. First concept, variation of electronegativity in a period. Can you see this table here? So we here second period is there and their electronegativity value. We have third period, their electronegativity value. For example, take second period and these values, no, they are on which scale? These are on a Pauling scale. Lithium has 1.0 electronegativity, beryllium 1.5, boron 2.0, carbon 2.5, nitrogen 3.0, oxygen 3.5, fluorine 4.0. How it varies along the period from lithium to fluorine? 1.0 to 1.5, 2.0, 2.5. ಏನಾಗ್ತಾ ಇದೆ? It is increasing, isn't it? Along the period, electronegativity increases. Look at the third period. Sodium, magnesium, aluminum and so on. Electronegativity of sodium 0.9, magnesium 1.2, aluminum 1.5. So along the period, electronegativity value increases, isn't it? Okay, what's the reason for this? ಯಾಕೆ? ಕಾರಣ ಏನು? You know, along the period, atomic radius decreases, isn't it? So from lithium to beryllium, beryllium to boron to carbon, nitrogen. So along the period, atomic radius decreases. This concept we know, this concept we studied, we learned in the previous class, isn't it? Okay? Atomic radius decreases along the period from left to right. So as the atomic radius decreases, as the size decreases, the attraction between outer or valence electrons and the nucleus increases. As the size go on decreasing, As the size becomes small and small, the attractive power between central positively charged nucleus and the outermost electron increases. Therefore, electronegativity also increases. The power of an atom to attract shared pair of electron increases. Therefore, since along the period atomic radius decreases, electronegativity increases. Okay, again the reason is what? Atomic radius concept. How it varies in a group of the periodic table. Look at this table over here. These are atoms of a group number 1: lithium, sodium, potassium, rubidium, cesium. Their electronegativity value in Pauling scale: lithium 1.0, sodium 0.9, potassium 0.8, rubidium 0.8, cesium 0.7. ಏನಾಗ್ತಾ ಹೋಗಿದೆ? Look at the another group number 17: fluorine 4.0, chlorine 3.0, bromine 2.8, and so on. What happens to the electronegativity down the group? It decreases. What's the reason? What's the reason for this decrease in electronegativity down the group? Again, reason goes back to the atomic radius concept. Down the group, atomic radius increases, definitely. Down the group hodagella, the number of shells increases, therefore radius increases, size increases. The attraction between the outer or valence electrons and the nucleus also decreases. As the size increases down the group, attractive force between positively charged nucleus and negatively charged electron decreases. Therefore, the tendency, the capacity to attract the shared pair of electron also decreases. ಹಾಗಾದ್ರೆ electronegativity down the group decreases, but along the period it increases. Okay, ಹಾಗಾದ್ರೆ in the periodic table, which atom has the highest electronegativity? Okay, so ಯಾವುದು? Fluorine. Fluorine is the element, atom, having highest electronegativity value in the periodic table because of its smaller size. Because of its smaller size, it has more power to attract shared pair of electron. In a Pauling scale, fluorine has 4.0. Next highest value irodu oxygen with a 3.5 Pauling scale electronegativity, and the third one is nitrogen with a 3.0, and so on. Okay, so adralli andre oxygen is highest, second highest is fluorine is highest, having highest electronegativity. Second highest will be oxygen. Okay, so this is about a small concept of electronegativity, its definition, different scales, and the variation of electronegativity in the periodic table. Okay, so with this we completed unit 3, that's classification of elements and periodicity in properties. Some more few concepts are there in this lesson. That's anomalous behavior, diagonal relationship, and some oxidation and reduction concept. Those concepts we'll see in some other chapters. Okay, so we'll study anomalous behavior and all in S block and P block element chapter. That's why I'm not covering those concepts in this lesson. Clear? So with this we have completed the third lesson. In the next class we'll move to the another lesson. Thank you very much for watching the video. Share this video to your friends. Subscribe to my YouTube channel. Thank you very much.